Okay, this one we're going to continue maximization and minimization problems. So this one is a minimum problem. So in this problem we have a factory that produces little plastic pieces to be sold to other manufacturers. The more pieces produced, the cheaper it becomes to produce those pieces. However, the cost will eventually go up as supply outweighs demand. According to the head accountant, the cost of producing X thousand plastic pieces can be modeled using the following quadratic function. Notice how this quadratic function has a positive a. That positive a is telling us that it's going to have this shape, which means that the vertex is down here and this is going to result in a minimum for us. So we want to find the number of plastic pieces in thousands that will minimize the cost of production. How do you know that solving this problem is using the vertex will result in a minimum? And that is how you know, because this parabola has an a that is positive, right? And so it's going to face up, which results in a minimum. So that answers our last question. So what do we need to do in order to do this problem? Why don't you give it a shot? Why don't you pause the video and try to figure out how many pieces it will take to minimize the cost. And while you're at it, you might try to find out what is the cost of the minimum amount of pieces that should be made. All right, hopefully you've paused and you've tried to do this on your own. So what we're being asked to find is we're being asked to find the vertex of this. And the x of the vertex is going to be the answer to our original question. The x, which is equal to minus b, all over 2a, tells us the minimum number of pieces required to minimize the cost. So now this problem doesn't require us to make up an equation or formula, right? It is already giving us one. That's the type of problem that we want if we want it to be easy. So what we need to find out is what is our B and what is our A. So our B and our A, remember, come from our original equation. So here's our A right here. It's not wanting to highlight it for me. Still not. There it is. That's our A. So this is 0.04. And then this one is our B. And don't forget that B includes this sign and not that X. It highlighted for me regardless that I didn't want it to. And this is a negative 8,504. So now that we know our B and we know our A, we can find out what our X is. So our x is going to be the opposite of whatever b is, and our b is a negative 8.504, and then we have that being over, and our over is 2 times whatever our a is, and our a is 0.04. So I'm going to go ahead and I'm going to say a negative and a negative make a positive 8.504, and I know 4 times 2 is going to give me 8, and I have 2 decimals and 2 more, two decimals, so I have 2 decimals in there, so I know that this is 0.08. Now I'm just going to grab my calculator and I'm going to calculate 8.504 divided by 0.08. So I will do that, and I'll write the answer down while this is paused. So dividing 8.0504 by 0.085, I end up with 106.3. Remember, if I'm going to do it by hand, I'd have to move the decimals out here, move the decimals out here, so I'm really dividing 8 into 850.4, and remember these represent thousands of pieces. Now if you wanted to answer my second question, which how much is the cost, or what is the minimum cost, then you're evaluating the function at this 106.3. So if I want to know the second question I asked, what is the cost? and that's the minimum cost, right? Because that is what we're minimizing, is we're minimizing the y value here. The minimum cost is this C of 6.3 thousand. And that means we're going to be substituting in for our x's 106.3, and we would get this resulting equation. And all I have is my really little crappy calculator, so I'm not going to even calculate this for you, but I'm just going to write it down so you could do that on your own. So that's negative 8.504 times 106.3, and then finally plus 25302. So that value, once you calculated it out, would give you the minimum cost for producing the number of pieces. So the next problem we're going to cover is a projectile motion problem. Now, projectile motion is a type of problem where we're dealing with any kind of object that is being thrown or launched. So this object could be sitting on the ground and then it's launched, it's gone up, and then it always comes back down because of gravity. Or maybe it's sitting up here and it's thrown up and then it's launched and it eventually hits the ground down here. No matter which one, the actual shape of the projectile is indeed parabola-shaped, and we can find out what the highest point is in its arc. So this is the independent, being the amount of time that it takes to get there, and the dependent being the height at that time t. So that's one of the things that we can find by using the vertex. We can find the maximum height. Now these type of problems are going to be maximum because they are going to be represented by a negative a value, because our thing that is acting on these projectiles is gravity, and gravity has a downward flow. So that's going to tell us that our a is negative. In fact, our a tells us about the speed of gravity, and that is actually a type of acceleration. So if you've ever had any physics, you'll understand a little bit about that, but that is what we're talking about with our a. And then the other thing that we might be interested in finding in one of these types of problems is when it hits the ground. So how long does it take to hit the ground? And this is a type of application of the x-intercept. And the x-intercept we can find by, just like we discussed before, letting y equal 0 and solving using either 1, our factoring, or 2, by using the zero factor property, or the square, sorry, not the zero factor property, that's the factoring one, or the square root property. And I showed you earlier how to use the square root property to solve with the vertex form. So when we factor, this is standard form. When it's square root property, that would be the vertex form. So let's investigate our two problems here. We'll probably get through the first one, and then the next one you can give a try on your own. So our first problem says, a rocket is launched straight up with an initial velocity of 100 feet per second. The height of the rocket at any given time, t, h of t, can be described by the following equation. So many times, instead of saying y is equal to negative 16 x squared plus 100x, these equations would be given instead as h of t the height at time t is equal to negative 16 t squared plus 100t. And that tells you the relationship between time and the height. Now, a couple of things actually that I want you to notice. I want you to notice this right here, and that value that I've just pointed out, this is our velocity at launch. So when we do this in physics, we call this v sub naught, or the initial velocity. And then the other one that I want you to notice is I want you to notice the negative 16 here. And this negative 16, that is gravity at work. And you notice that it's negative. That's because gravity pulls down. And this one is gravity in feet per second per second. And the gravity's effect in feet per second isn't always going to be the case. Sometimes we might want to deal with meters per second. And in that case, you would see a different number, a negative 1.9. Now, that's not to say that none of those numbers appear, because maybe something's been factored out already for you. All right, so what I'm going to do now is I'm going to find the time for the rocket to reach the ground. Well, if I want to know how long it takes for it to go up and come back down and hit the ground, that's wanting to know the time of this x-intercept. So I need to know the x value for this x-intercept. So my intercept is going to be found by solving that equation for y equals 0, or h of t equals 0, right? H of t, the height of the object at time t, is 0 because it's hit the ground. And where's the ground? It's 0, right? Ground 0. You've heard that a bazillion times, I'm sure. So this is negative 16 t squared plus 100t is equal to 0. Now, this one is quite an easy one to solve, actually, because we're just going to factor out t. So this is t times negative 16t plus 100. Now, this one is going to give us t equals 0, or negative 16t plus 100 is equal to 0. The first one, the t equals 0, this one is a no-brainer. T equals 0, that is what we would call an extraneous solution, because we know that t equals 0. At time 0, the object was launched at the ground, right? So t equals 0. Yes, that's what that tells us. Sometimes it gives us a nonsensical answer where it says, oh, it's equal to negative something. Well, that's the case where it's launched from above the ground and it's telling us about this time to get back to the ground, which doesn't make any sense in the real world. So this one is what we would call an extraneous root. And now we just need to change or to solve the other one, and that's going to give us that 16t is equal to 100 if I add negative 16 to both sides of the equation, and then t is equal to 100 divided by 16, and then I'm going to reduce this by dividing by 4. 4 goes into 125, 4 goes into 16 4 times, and then I'm going to go ahead and divide that out so that I get a fraction, or a decimal, depending upon which way you want to look at it. So 4 goes into 25 6 times with 1 left over, and I can either write that as 6 1/4, or I could write that as 6.25, and this is time, and this time is in seconds. So it will take 6.25 seconds for it to hit the ground. Now I am out of time here, so I'll catch you in the next video.